In chemistry, the simplest scenario we can have is to have 100% of any energy change happen as heat. In other words, we're not going to be doing any work. However, we also will have work done sometimes, and in fact most of the time, unless we take special measures to keep our system so simple that everything ends up being heat. Now let's try to get a little more picky there and also take a look at some of the sign conventions that are going to be so important in both of these cases. Now if we have a heat transfer process, that means only temperature changes are going to occur because heat energy is being passed between your system and your surroundings. Now be very careful there. Heat is not the same thing as temperature. When the heat energy is transferred between materials, the same amount of heat energy will cause a different temperature change. We need a conversion factor to convert from heat energy to temperature units, and we'll see that when we talk about heat capacities. Now that said, that's going to be the key thing you're going to observe. If there's a heat transfer, you're going to have a temperature change in one of those places. So here's two different examples. If I have a Bunsen burner set up beneath the beaker, the fire is creating lots of heat, and it's warming up the beaker. Since I probably care most about what's happening inside the beaker, that would be my system. The fire, the Bunsen burner, the air around that would all be part of my surroundings. Now that said, you could also imagine a case where what you care about measuring is when I pass a certain amount of gas into the Bunsen burner and burn it, how much heat energy is produced. At that point, your system would be your flame. Your surroundings would actually be the beaker of water. And you might be measuring the temperature in that beaker of water and using your heat capacity to say, aha, I see how much heat energy has been transferred into my surroundings. Now I know how much heat was produced in my system. So always remember, system and surroundings are going to be completely contextualized based on what you're talking about and what you're trying to do with it. Now that said, I think we can all agree that the thing we care most about with our refrigerator is how cold it's keeping our food. I don't want melted ice cream, at least not coming out of the freezer. Once I let it sit in the bowl, sure, I love eating melted ice cream. But that's not the point of the freezer. The point of the freezer is to keep it cold. Since this is cold, obviously we're pumping the heat out of our system and into the surroundings. And you felt that if you've ever stood in front of the refrigerator with bare feet and felt the warm tiles in front of it, or if you've pulled the refrigerator out from the wall in order to clean and you felt how warm it is back there by the wall, it's because you're pumping the heat energy out of your system and into these surroundings. Okay, so that's some of the context of what we're talking about there. Now let's also bring up work. Work is going to be all other energy transfers that are happening. Mechanical, electrical, etc., etc., etc. In other words, we'd be performing work because coming from the refrigerator, we also have a power outlet. And that power cord plugged into the power outlet is going to be transferring energy. Since we'd be transferring energy from, I'm going to call it the surroundings, my wall socket, into the system I care about, I need to be able to think about how the energy is flowing for that as well. Now for that, we need to consider some sign conventions. Now, anytime we have a change in energy, it's going to be a combination of all of our changes in heat and changes in work. So the total amount of work that I do and the total amount of heat that I do are going to be combined into delta E. Now, for heat, it's going to be a positive value if it's going into the system. Let me just point at this one for a second. As I'm putting heat into my beaker, I'm seeing the amount of heat energy increase. And as a result, with some different math that I'll do, I'll be able to see the temperature also increase. Right now we're going to focus on the temperature, on the heat. The heat energy in that beaker has increased. Positive sign. That also means that the heat of the surroundings is decreasing. The heat energy is being used to warm up inside of that beaker. And when it does, the energy is transferred from one place to another. The system has gained heat. Heat was lost to the rest of the universe, so heat will be decreased. Now, here's a weird one, though, in terms of the way that you think about it. At least a lot of people have a weird time with this particular sign convention for work. Work increases when it's done to the system. Work decreases when it's done by the system. Most people are thinking of a system doing work, and they might want to think of that as a positive number, and it's actually not. The key thing to remember is we're talking about the system as being kind of the root of our jargon. And since it's the root of the jargon, it's also going to be the root of the math. So if the energy is increasing inside of my system, work was done to my system. If work is coming out of my system, that's going to be a negative change in energy within my system. You can think of that as being a compressed piston. If it starts pushing outward, it's relaxing all that energy that's been pent up inside of that compressed cylinder. By pushing on the outside world, it's done work on the surroundings. It's moved air around. If instead we push in on that cylinder, work was done by the surroundings to the system, energy went into the system. That's the way you can think through the signs.